Australian mathematics curriculum, we're looking at Pythagoras' theorem word questions. A frequent type of question we get is we're asked to show whether a triangle is right-angled. Now normally, if we want to know if a triangle's right-angled, there's a little right-angle sign in it, like this. But these triangles have 3 numbers showing, but no right angle. We have to work out if they're right-angled. The rule is c squared equals a squared plus b squared, and that's Pythagoras' theorem, and it only works for right-angled triangles. So if that equation is true for one of these triangles, we know that triangle must be right-angled. So we test it. Start with the first one. Label the sides. Remember, the longest side must be C, and the other 2 sides can be A and B, and it doesn't matter which is which. Write Pythagoras' theorem, c squared equals a squared plus b squared. And we'll substitute in the values. C, I've got 13 squared, a squared, 5 squared, plus b squared, and b is 12. Evaluate each of these. So 13 squared is 169, 5 squared is 25, plus 12 squared, which is 144. Then we check, and use a calculator if you want. 25 plus 144 is also 169. Since it worked out that c squared did equal a squared plus b squared, we can say yes, this triangle is right-angled. Sometimes we'd have a word answer. Let's have a look at the other triangle. Write our formula, c squared equals a squared plus b squared. Label the triangle. The longest side is always C. A and B are the 2 shorter sides. Substitute the values in. 16 squared equals 8 squared plus 15 squared. Evaluate each of these. 16 squared is 256. 8 squared is 64. 15 squared is 225. We add up 64 and 225, and we discover that it equals 289. That's not equal to 256. So put a line through, not equal. So c squared did not equal a squared and plus b squared for this triangle, so it is not right-angled. So this type of question uses Pythagoras' theorem the other way round. Normally we've got a right-angled triangle and we find some sides. This way we check if the 3 sides we have fit Pythagoras' theorem to see if it's a right-angled triangle. another type of question we may find. This one here. Ms. McClintock's house is on a hill near a road. And we've got a lot of words happening here. The house is 83 meters above the level of the road, and the horizontal distance from the road is 450 meters. Find the direct distance from the road to the house. So these questions can be a little bit tricky. Sometimes they help us by starting the diagram. The language is what we want to know. Start at the end here. The end sentence of any word question has the actual question in it most of the time. The rest of it has information. So the question is, find the direct distance from the road to the house. When they say direct distance, they mean in a straight line. So in this case, it's where I've put that little dotted line there, straight up the hill. Direct distance, a straight line from one to the other. The information that we are given. The house is 83 meters above the level of the road. When we see above, or when we see vertical distance or up, we want straight up. So straight up from the same level as the road, but not near the road, is the house. And then they say the horizontal distance from the road. That means go from the road and horizontally go across until we get to straight under whatever the object is that we're dealing with, my house in this case. And because horizontal is straight across and vertical is straight up, I know that has to be a right angle. So the aim with interpreting the question is to draw a diagram that has a right-angled triangle. Once you've found your right-angled triangle, redraw it without all that complicated stuff. Right-angled triangle, and go and put our numbers in. They said we had to find the direct distance from the road to the house, so that distance that we don't know is going to be x, or a, or c. C is much better, of course, for hypotenuse. They said 83 meters above the level of the road, so the distance up was 83 meters, and the horizontal distance was 450 meters. So most of the word question is about reading it and trying to work out where the values are in the triangle. Once we've got a triangle, it's not too difficult. We discover that we want to find the longer side. That's c squared equals a squared plus b squared. We substitute in our values. X squared equals 83 squared plus 450 squared. And we'll need to evaluate those. It's going to be large numbers. 83 squared is 6,889, and 450 squared, 202,500. That's x squared. We're still going to have to add those together. A very large number. And we'll need to find the square root of that just to get x. So we write it under the square root sign, and the square root, is 457.6. That is x, and that is the direct distance from the road to the house. My other measurements were in meters, so that's in meters. We've got our answer. Since it was a word question, we should write a word answer. Therefore, the house is 457.6 meters from the road. Now, one more question. We often see word questions with ladders in Pythagoras. And again, it's just about getting our terminology, the words, right to give us the correct diagram. We're running out of time. We might not solve this one. A 3-meter long ladder is leaning against a wall. Start your diagram. There's a wall. It's got ground underneath it, and the ladder leans up against the wall. Preferably use a ruler, but this book doesn't like rulers, I'm sorry. And that ladder is 3 meters long. They told me it's a 3-meter long ladder. A wall and the ground, we assume it's at right angles. It better be if it's a well-built wall. The foot of the ladder means the bottom of the ladder where it's touching the ground. And it's 80 centimeters away from the wall. So that distance there is 80 centimeters. And it says, how far up the wall does the ladder reach? They want to know from the bottom of the wall to the top, how far does the ladder go? So that will be our x. They've been a little bit tricky in this question. They've given me 80 centimeters here, but the other measurement is 3 meters, so we'd better convert 80 centimeters to meters, 0.8 meters. Once we've got our diagram, it's just Pythagoras' theorem. C squared equals a squared plus b squared. We're finding a shorter side, so if we prefer, we can use a squared equals c squared minus b squared. Our unknown squared is the hypotenuse squared minus the other side squared. And since we're running out of time, I'll leave you to work that one out. Pause it, work it out, think it through. And here's our answer. You can check you're working. The ladder reaches 2.89 meters up the wall. Check your answer, and we're done.